Hello and welcome back. In this video we'll continue looking at confidence intervals, and we will construct confidence intervals for the variance and standard deviation of a population. So let's review some of our notation. For the population we use sigma and sigma squared to mean the standard deviation and the variance respectively. For a sample we'll just use s and s squared for the standard deviation and variance. N is going to be our sample size, so the degree of freedom is going to be n minus 1. And the left and right critical values for the chi-squared distribution, we use chi sub L squared and chi sub R squared. Now, before we do anything else, there are a couple of requirements before we can use the following information to construct confidence intervals. And the first one is maybe the most important one. The population must be normally distributed. This was something that we saw was a requirement for means, but we had an alternative. Either the population must be normally distributed or the sample size has to be bigger than 30. For confidence intervals for variance and standard deviation, just having a large sample size, being bigger than 30, is not good enough. The population must be normally distributed. If the population is not normally distributed, the chi-squared distribution doesn't apply, and everything that we're doing doesn't really make sense. So the population has to be, absolutely must be, normally distributed. And then the second one is the same as all the rest of our confidence intervals. We have to be looking at a simple random sample, where everything in the population had an equal chance of making it into our sample, and we're not doing a clustered sample or a stratified sample. So the confidence intervals will look like the following. We've got our formulas here. So the confidence interval for the variance looks like this. And we can see that the variance of the population will be between two numbers. Those two numbers depend on n minus 1, so the degree of freedom. The sample variance that we found, which is s squared, and the critical values for the left and right sides of our chi-squared distribution. And the standard deviation is just a square root of the variance, so we take square roots of everything, and everything just pops out. It's not too bad. We just take square roots of everything. One thing to notice is that the chi-squared, the critical values for the chi-squared distribution on the left and right have switched sides, but it will make sense when you're doing the calculation which one goes on which side. And this is something I'll point out when I do a calculation in a little bit. Maybe what you'll notice though with these standard deviations, they don't look like, with these confidence intervals, they don't necessarily look like the confidence intervals that we saw before. The confidence intervals that we saw before, so for instance for the mean, looked like the sample mean plus a little bit, and the sample mean minus a little bit. So the population mean was somewhere between the sample mean plus and minus a little bit. Here, we're not taking the sample standard deviation and sample variance and adding and subtracting a little bit from it. This is because the distribution, the chi-squared distribution of the sample standard deviations, is not symmetric. So we would have to add a little bit more to one side and subtract a little bit less from the other side to match the distribution. So we don't do that here. We don't add and subtract a little bit because it is unbalanced. The margin of error would be different for the bigger side rather than the smaller side. And because it's not symmetric, we wouldn't expect the middle of the interval to really mean anything. One half of it should be longer than the other half, so it doesn't make sense. So we just have our formulas here and we just apply them. So let's go through an actual example to see how we might construct these confidence intervals. And I'll do so in two different ways. So listed below are going to be speeds in miles per hour measured from traffic on some day. So they tell us that this is a simple random sample, and we'll assume a normally distributed population. So we'll assume that the values, the speeds of cars driving by are going to be normally distributed. So from the sample, they tell us that the standard deviation of the sample is 4.387, and the variance is 19.242. And we are being asked to construct a 99% confidence interval. So what do we need to know for the confidence interval for the standard deviation and the variance? Well, let's do the variance first. Well, we need to know n, which is the size of our sample. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So n is equal to 12. So our degree of freedom here is going to be 12 minus 1, which is 11. So we have n. We have our variance. The last piece of the formula here is going to be the critical values. So now we need to find the critical values, and this isn't too bad. If we come back to our StatCrunch, we can open up our calculators and find the chi-squared calculator, and we want a 99% confidence interval. So if I draw a picture really quick, I find that this always helps me. We want a 99% confidence interval. So we want the area between our critical values to be 99% or 0.9. So the last 1% should be split up into both of our regions to the right and to the left. So if those add up to 1%, then I should have 0.5% on this side, excuse my furnace, and 0.5% on the other side. So if I come back to StatCrunch, I want the area to the left to be equal to 0.005, as in 0.5%, and then the degree of freedom should be 11. So we get 2.603 for our left critical value. 2.603, if I'm rounding to three decimal places. If we try to find the right critical value, now we want this over here, and we want the area to the right of this value to be again 0.005 with the same degree of freedom. So this is going to be 26.757. Okay, so now let's plug it into our formula. The variance of the population should be between n minus 1, which is just our degree of freedom, times the sample variance divided by the left critical value, and on the bottom we'll have the same thing, except we'll have the right critical value. So let me plug in these numbers in here into a calculator. So so on this side, this is going to be 11 times 19.242 all divided by 2.603. On this side, we've got 11 times 19.242, all divided by 26.757. And when we plug these in, on the left-hand side, on the right-hand side, we'll get 81.34. And on the right-hand side, on the left-hand side, excuse me, we'll get 7.911. I don't know why I didn't write one more decimal point over here. So here is our confidence interval for the variance. Now, notice that if we accidentally wrote the chi L and the chi R in the wrong place, we would have something that looked like this. 81 is going to be less than sigma squared is going to be less than 7.9. Well, this doesn't make sense because 81 is not less than 7.9. The bigger number has to be the bigger number according to this. So if you switch the order around, you should notice, because the bigger number has to be the bigger number. 81 is bigger than 7, so 81 is going to have to be on this side. So you will notice when you get these numbers wrong. The standard deviation, on the other hand, the population standard deviation, is just going to be the square root of both sides. So after we take the square root of both sides, we'll see that our standard deviation should be between about 2.813 and 9.019. So this is, after a little bit of rounding, this is our confidence interval for sigma, which is our standard deviation, and we have our confidence interval for our variance. Now, when we are given the values explicitly in our sample, we can plug them into StatCrunch here. So these are all of our speeds, and I've just listed them in here. We've got 12 of them, and we can calculate the confidence interval for the standard deviation in a very straightforward way. Again, we can come over to STAT, and we can look at the variance statistics. We only have one sample, and my face is in the way, but and we want to look at this sample with data. So we're actually given the data values, so we can calculate this. So we want the speeds column. We are not computing a hypothesis test. We are computing a confidence interval, and the level for the confidence interval is going to be 99%, and the rest of this doesn't matter. So we can compute this, and what we'll see is that this comes up with the lower limit and upper limit for the variance of our speeds. So the lower limit they have is 7.91, we round it to 1, which if we compare this, 7.911, that's perfect, and 81.309, so it looks like I must have rounded just a little bit because they're only a little bit off. And then the only sad thing is that this doesn't tell us our standard deviation, but the standard deviation is just going to be the square root. The upper and lower limits are just going to be the square roots of the upper and lower limits for the variance anyway. So those are fairly straightforward to calculate. So again, you can do this directly using the formula, or if you have the actual data values, you can plug it in to StatCrunch.